Hello everyone, in today's video we are going to talk about types of graphs or charts or statistical presentations. So the first one that we are going to discuss is all about pictograph. A pictograph uses an icon to represent a quantity of data values in order to decrease the size of the graph. A key must be used to explain the icon. So the icon, it may be a drawing or a picture. And then below the pictograph is a key wherein it explains about the icon. Here are the advantages and the disadvantages. For the advantages, it is easy to read, visually appealing, handles large data sets easily using kid icons. And for the disadvantages, it is hard to quantify partial icons, like if we have one half, three-fourth, so it's difficult to draw. And then icons must be consistent size. So when you draw something, like it should be consistent. Best for only 2 to 6 categories, and then it is very simplistic. So if we have these tally marks in the number of pets for children, to convert it to pictograph, we are going to use this icon. So this icon stands for 2 votes. So along the cat, it is 2, 4, 6, 8, 10, which is equivalent to our tally marks, which is 10. And then for the dog, 2, 4. So there are 4 tally marks for that. And for the hamster, we have 2, 4, 6. So we have 3 icons in here, which is equivalent to 6. So this is the key wherein it explains about the icon. So each icon stands for 2 votes. Now let's move on to bar charts. Data that is counted and has no in-between value is called discrete data, which we learned in our previous lesson. So discrete data is usually collected in a frequency table and then presented as a bar chart. And another information about discrete data, it can be counted. So a bar chart has a horizontal axis and a vertical axis. So as you can see here, the type of pet is the horizontal axis and the number of children is the vertical axis. A bar chart must always have a title explaining what it shows. So in our bar chart, the title is a bar chart to show how many pets children have. Bars must be carefully drawn to show the data. So if we have, for example, the number of children who like cat is 12. There are 12 children, so it should be here. And if the data tells us it is an odd number, so it is in between two even numbers, because in our bar chart it starts with 0, then 2, 4, 6. So if we have 7 in here, it is between 6 and 8. There must be a gap between each bar. So a gap between bars. So for the bar of cats, there is a space in between for the dogs. Each bar must be the same width. So as you can see here, they have the same width. A number line is marked on the vertical axis. The scale of this number line is chosen based on the data range. The data categories are organized on the horizontal axis. So this is the horizontal axis. Each axis must have a label explaining what it shows. So for the horizontal axis, we have the type of pet. And for the vertical axis, it is the number of children. So always have the label for each of the axes, so that when the readers see this bar chart, they know how to interpret the table. Now let's move on to comparative bar charts. Discrete data in each category can also be represented in subcategories. We can draw a group bar chart to show this data. In this bar chart, each category has more than one bar. A key is used to identify the subcategories of the data. So in here, for the orange are the number of boys, and for the yellow are the number of girls. So in each of the category, there is a subcategory which is the boys and girls. So this is comparative because we are comparing the number of boys to the number of girls when it comes to the type of pet that they want. So let's move on to line graph. So in here, we will gonna learn when to use line graphs at its best. So line graphs are used to show changes to a measurement over time. They show continuous data. And then going back to our previous lesson, we all know that continuous data are the data being measured. So for example, temperature, weight, height, time. So those are few examples of continuous data. So the data being measured is shown on the vertical axis, and the time the data is being measured over is shown on the horizontal axis. So in our example, this is a line graph to show the temperature of the classroom. So along the horizontal axis is the time, and along the vertical axis is the temperature. So we all know that time and temperature are under continuous data because they can be measured. So data is plotted onto a line graph in the same way as the coordinate grid. These data plots are then joined with a straight line. So you learn how to plot points in a coordinate plane, and that is how we plot the data on this line graph. So the x comes first before your y, so the time comes first before your temperature. We can use the line of the graph to describe general trends in the change of the measurement over time, or to find precise measurements at a given time. So most of the time, the line graph shows the relationship between two variables. So as you can see here, what is the change in temperature at a given time? And sum is the relationship between the height and the weight. Now let's move on to the last type of chart, which is the pie charts. So pie charts show discrete data as proportional sectors of a circle. So as you can see here, the pie chart and the bar chart show discrete data. So data that can be counted. But in pie chart, your keyword here is proportional. So it shows the relationship of a certain variable to the whole of the data. So every sector of a pie chart is a proportion of the whole. So you can explain what each sector represents using an angle, fraction, or percentage, depending upon the given data values. Being able to convert between fractions, percentages, and angles is a skill for answering questions about data presented in a pie chart. So I will explain later on how to make the precise or accurate angle measurement in each of the pie. So if we have this pie chart, this shaded region, which is color orange, so the data in this sector is one half of the whole amount. So it is 50% because we all know that one half equals 50% and 180 degrees. Where does 180 come from? So we all know that in a circle, it is equivalent to 360 degrees. So since it is one half, so we are going to divide it by 2. So 360 degrees divided by 2, it is equal to 180 degrees. Then if we have 1/4, so the data in this sector is 1/4 of the whole amount, it is also 25%. So 1/4 equals 25%, and 360 degrees divided by 4 is 90 degrees. So that is where 90 degrees came from. Now, half of 1/4 is 1/8. So the data in both of this sector is 1/8, and it is also 12.5%. So where did 12.5% came from? It is 25 divided by 2. And then 45 degrees. So 360 degrees, the whole of the circle divided by 8. It is equal to 45 degrees. So we can use fraction, percentage, and angle equivalents to interpret the data in a pie chart. So it depends upon the computation that you are going to do. Is it for fraction, for percent, or angle measurement? If the whole pie chart represents 120, for example, the value of the orange sector will be equal to 60. So you just need to divide it by 2. And take note, the angle at the center corresponding to a particular observation component is given by the following formula. So value of the component over the total value times 360 degrees. If the given is a number, for example, so you just need to divide it by the total data values times 360 degrees. But if the data is expressed in percent, all you need to do is the percentage value of the component over 100 times 360 degrees. That is how you construct the precise angle measurement for each of the sector in a pie chart. So that's it for now. Thank you for watching. Please do your practice worksheet number 8 in the Google Classroom, and see you again next time. Bye!